When studying Learning Aim B for sound recording, there are 3 different sections that you need to consider and respond to. The first is understanding different principles of sound, which I will talk you through in this video, the science behind sound, as well as examples of how to record these sounds, which usually we evidence in experiments as part of a group-based workshop. The principles that we study are the Doppler effect, sounds at different altitudes, sound refractions, reflections and diffraction. The Doppler effect. So the Doppler effect is the increase or the decrease in the frequency in sound or light or other waves, depending on what source you're measuring, as the source approaches the observer. The wavelength of the sound from the moving object is compressed ahead of the source and expanded behind the source, creating a sensation of a higher and then lower frequency than what is actually being produced by the source, as you can see on screen in this animation. Now you're going to hear the sound of an ambulance driving by, and you'll clearly hear the difference between high and low frequency in this sound clip. When it comes to you demonstrating your ability to do the Doppler effect, you're going to want to either stand next to a roadside and capture a police car, an ambulance, or maybe with a fire engine passing you by, or it could be that you have some kind of horn that passes the microphone if you're standing in the field. But either way, when you're capturing the Doppler effect, you want the high frequency and the low frequency difference. So you need to capture the before the sound approaches you and after the sound approaches you to get the best example. Sound at different altitudes. Sound travels at different speeds and at different altitudes and temperatures. For instance, in warm climates, sound travels quickly compared to colder climates where it is slower. Therefore, the higher up you are, the colder the temperature is, and therefore the sound travels much slower. How would you test this? You could test it on the links, as the ground is much higher there. However, you will need a windshield to protect the quality of your sound recording, otherwise it will be ruined. Sound refraction, reflections and diffractions. Sound refraction is how sound travels through an object and has changed within the process. Sound travels faster in some materials than others. Sound waves travel outwards in straight lines from their source until something interferes with their path. Sound changes through different mediums, i.e. different materials. An angle other than 90 degrees is bent from its original direction. The change in this angle of the direction is called refraction. Because of the angle, part of the wave enters the new medium first and then changes speed. When you put a straw in a glass of water, you can see how it's slightly bent. That's also an example of refraction, but that's using light instead of sound waves. The difference in speed causes this wave to bend. The velocity of sound in each material is determined by the material's properties, so in terms of its density, its elasticity, etc. for the material. Refraction, otherwise known as bending of sound waves, is accompanied by change of speed and the change of wavelength of the waves. When sound enters the new object, its speed has been changed as well as its wavelength. So now you know how to explain what sound refraction is, but how do you demonstrate it? Well, there are 2 methods you can use. The first experiment you can do is called the carbon dioxide experiment. So what you would do is you would need to fill up a balloon with carbon dioxide. The best way to do this is to get a balloon, get a regular Coke bottle, probably a big one, and put some bicarbonate soda in it. Shake it about, and together that will make some kind of carbon dioxide releasing gas, and then capture that air in the balloon and trap it tight. You might need a couple of bottles and quite a bit of bicarbonate soda to make this work, but maybe do 3 or 4 balloons. Then you want some kind of way to play sound, so some kind of speaker. Then you want to download an oscilloscope app, okay, and a microphone that will obviously plug into that to record the sound. So you have one speaker on one side, then you will place the balloon in the middle, and then have your oscilloscope on the other side. And when you move the oscilloscope with the carbon dioxide into the middle between the speaker and the oscilloscope, you will see that on the sound waveform, on that oscilloscope that the frequency has changed, and that's because sound travels differently through carbon dioxide compared to just regular air. I'd also just fill up a balloon with just air so you can see the difference. The second experiment you can do is using two tuning forks, a table, and just some water in like a test tube. So bang the tuning fork on the table and bring it up to the microphone so you know what that sounds like. And then you stop the tuning fork, bang it on the water, and then bring it up to the microphone, and you will see there's a difference in the frequency heard in the sound. That's two ways that you can test refraction, and you can talk about the differences. Sound diffraction is when sound waves meet a gap and carry on through the gap. So, in other words, if I was shouting at you from one side of the door and I had the door slightly open, the sound would carry on through, but this wavelength would slightly change depending on how open or closed that door was, and that's why sometimes it's more difficult to hear through a particular object because a lot of the sound is being absorbed into the object. However, waves spread out to some extent into the area and beyond the gap. This is known as diffraction. The extent of the spreading depends on the width of the gap compared to the wavelength of the waves. The extent of the spreading depends on the width of the gap compared to the wavelength of the waves. We are able to hear lower frequencies around a corner because of the longer wavelengths refract or bend more easily around objects than short ones do. So in other words, if something's a little bit lower in tone, you're more likely to hear that than something higher in tone. So now you know how to explain what it is. How do you go about demonstrating what it is? Well, the easiest test that you can do is by shouting through different objects using female and male people as your example to show how the different frequencies react. So what I would do personally is have your person who's going to shout in a different room and maybe have the door slightly ajar but not all the way, and get them to say a sentence. So get a boy to do that and then get a girl to do that, and then you can test how the sound frequency changes with the tone of the voice, obviously between a male and a female's voice being higher or lower, but also about how much of the sound you're picking up through that doorway because of the type of gap that's being left. And I would experiment with different places, so where you can hear sound more clearly. So maybe you might want to try diffraction through glass. Maybe you want to try it through a doorway. Try using it to record sounds in different places through different objects. Sound reflection is how sound travels and bounces off objects to reach you. Depending on the object that it is travelling from will produce a different effect. For instance, if sound hits a hard solid surface, it is reflected back and causes an echo of the original sound, but travelling back towards the sound source. Whereas, if a sound hits a soft surface, like a fabric or upholstered chair or sofa, it is absorbed and does not muddy the clarity of the original recording. Recording studios are acoustically insulated so that sound is not reflected but absorbed, allowing the sound quality to remain high. Testing this kind of sound procedure is quite easy. So you might want to try different sound environments such as a hall and how that echoes because it doesn't have the absorption of furniture to take some of the sound waves. Compared to maybe like the recording studios in school, or how a classroom is different to somewhere else outside, or somewhere that's got lots of furniture and how that records differently. So you want to try and experiment and record in different places, again using different voices as well, male and female voices, and how they get absorbed into wherever you're recording.